Hi guys. Today we're going to look at section 3.7 from the book, which is on inverse functions. The first thing we're going to talk about though is one-to-one functions. So just recall, a function is a set of ordered pairs where it has the property that no first element is repeated at all. And these examples here are, all three of them are functions. The first one, you can tell it's a function because if we look at our our x values, we got 5, 4, 7, and 0. None of those are repeated. Now, the way we'd probably check the others is by looking at the graph. This one, y equals x cubed, looks like this, and that passes the vertical line test. Any vertical line I draw through this is only going to touch it in at most one place. And same for y equals x squared. If we graph that out, it looks like this. And any vertical line we draw through there is going to touch it in at most one place. I guess in both of those cases they touch in exactly one place, but still, they pass the vertical line test, so they are functions. But what I want to talk about today is one-to-one functions. A function is one-to-one if among the ordered pairs, no two have the same second element, or in other words, there's no repeated y value. And if we go back and look at the three examples up above, this one is not one-to-one. Because the y value 3 is repeated, and the y value 4 is repeated. So we have repeated y values, and therefore it's not one-to-one. Now, for y equals x cubed, we want to look at this and say, of all these points along here, do any of them have the same y value? And the answer is no, because the y value is strictly increasing the entire time. So this one is one-to-one. And on the last function, y equals x squared, can we look at that and find a function that has, find a y value that's repeated? The answer is yeah. If I just draw a horizontal line across there, I'm going to find, I'll do that in blue. If I draw a horizontal line across there, it's going to give me a point here and here that has this 2 points that have the same y coordinate. So this one is also, whoops, this one is not one-to-one. And this sort of brings us down here to the horizontal line test. A function is one-to-one if and only if no horizontal line intersects it in more than one place. And the horizontal line test works just like the vertical line test, except it determines if something's one-to-one rather than determining if it's a function. I have my UWG cup here. All right, let's look at some examples. Which of these functions are one-to-one? So I'm going to do these just by looking at the graphs. So y equals absolute value of x. If I draw that in, it looks like this, and we can draw lots of horizontal lines here that touch in more than one place. So this one is not one-to-one. Okay, y equals 2 to the x. You might not know what y equals 2 to the x looks like, but it looks more or less like this. It's got an asymptote there. Tell you what, let's do. Let's look at it on Desmos just to get a better look at it. If I graph y equals 2 to the x, move myself in here. If we graph y equals 2 to the x, we can see it looks like that. Now, if you look at it, there is no horizontal line that will touch it in more than one place. You might wonder about it down there where it looks like it's going flat, but the truth is, if we zoom in on it, this never actually touches the y-axis. It gets really close, but it never actually touches it, and therefore any horizontal line that we put in I'm not sure why it won't give me a slider, but if I put in a horizontal line of say 0.01, This line only touches it in one place. Touches it somewhere around there, and then over here, it's the lines above it. So this does pass the horizontal line test, and therefore this function is one-to-one. All right, the next one, if you've done any trig before, you can probably answer this one right off. But let's say you haven't done any trig. If we just graph y equals sine x, and let's zoom back out to something normal, you can look at this and see there are lots of places on this graph where you could draw a horizontal line and it would touch it in infinitely many places. Whoops. So this is not one-to-one. All right, this next one, honestly, I can't look at it and tell the answer because this is a cubic function. Now, cubic functions can look like, if we just had y equals x cubed, that one is one-to-one because it's increasing. But if we put in, let's see, x cubed minus x squared plus x, when we look at that, this function, we can see it is always increasing. And honestly, without calculus, there's not a good way to determine if it's always increasing. So this is going to be, this one is also one-to-one. Now, an interesting thing, if we change the function a little bit, say maybe make this a 2 here, or something bigger, we can get cubic functions that are not one-to-one. But this particular one is one-to-one. All right, let's look at another. Let's look at this next example. This next example says which linear functions are one-to-one, and a linear function is just a line. You know, y equals mx plus b. Well, if we look at that, most lines are going to be one-to-one. That's one-to-one. If I changed my slope around, you know, most of these are one-to-one. The only time that we wind up with something that's not one-to-one is here, when the slope is 0. Because notice, if we take the, if you look at that, every point on that line has the same y coordinate. In this case, it's 1, but whatever it is, it's going to be your b. So which linear functions are one-to-one? Which ones are one-to-one? All linear functions are one-to-one, except for when m equals 0. All right, let's look at a couple more. We could just graph these and get the answer. Is this polynomial one-to-one? This first one is y equals 3x squared minus 5x plus 1. Now, you could graph that and look at it and figure out if it passes the horizontal line test. But if you look at this one and think about it, you can actually determine the answer without doing that. This is it's a parabola because it's got x squared is the highest term. Let me write that out a little better. The graph is a parabola. And since the coefficient on x is positive, it's a parabola that opens upward. Now, really, opening upward or downward isn't that important for this question, because if we know that the graph is a parabola that opens upward, somewhere on there, once you get above the vertex, every horizontal line is going to hit it twice. So this is certainly not one-to-one. And if you've got any parabola, instantly it can't be one-to-one. Now this next function, we've got y equals minus x to the fourth. So this is a fourth degree polynomial. If you don't know much about how the graphs of polynomials are, whenever they're even degree, both ends are going to go the same way. Either they're both going to go up if the leading coefficient is positive, or both ends are going to go down if the leading coefficient is negative. So on this one, even degree, leading coefficient is negative. So that tells us that the graph is going to look like this. On this side, it's going to go down. In the middle, it's going to do some stuff, whatever. And on the other end, it's going to go down as well. So that tells us somewhere in there, if you go down far enough, you have to hit a place where the line touches it twice. So this is definitely not one-to-one. So let's just play with that for a second on Desmos, because I think it's worth looking at. If I go over here and I'll put that actual function in. It was y equals negative x to the fourth plus 4x cubed plus 3x plus 1. And if you look at it, sure enough, it looks kind of like a warped parabola or something. But there are definitely places on there where you can draw a line and it touches it twice. Now, if I change some of these numbers inside of here to some other, let's change it to a different fourth degree polynomial. If I change this to a negative, notice we still get even more places where the horizontal line touches it more than twice. But it doesn't really matter as long as you've got an even degree. It's going to fail the horizontal line test. I change this to x to the 6. Really what we're looking at here is called the end behavior of the polynomial. Like x to the fourth, both ends are going down. If I make it, well, that's because it's negative. If I make it positive x to the fourth, both ends go up. And no matter what junk I add onto the end with smaller terms, it changes what's going on with the parabola. I'm sorry, I shouldn't call it a parabola. It's not a parabola. It changes the shape of the graph. But the only things that affect the end behavior are the leading term. All right. So the main thing to take away from this this video is the concept of being one-to-one and the horizontal line test. So I'm going to stop this video here. In the next video, we're going to look at we're going to look at inverse functions, which is related to one-to-oneness.